of this lab was when you dissolve sugar. So basically you took a cap full of sugar and you took some water and you weighed them separately or weighed them in different containers at the same time, so you got a total mass. Then you mixed them together, shook them up and dissolved the sugar, and you weighed it again. You should have gotten close to a zero change in mass because you shouldn't have spilled anything if you were careful, if you were precise in your measurements, but it should have been close to zero. Some people may have got a more positive, some people may have gone more negative, but if you got a very large positive or large negative change in mass, you probably didn't do it very carefully. So how are we going to represent what happened here? So now we had the vial here, and let's say we had the cap full. Here's the cap. In here we had X's, and this X's we had the water. So the X's are H2O. And here, let's say we have circles. This is the sugar, so the circles are equals to sugar. And if you remember what sugar's formula is from biology, C6H12O6, 6 carbons, 12 hydrogens, 6 oxygens. We basically took this and dumped it in the water and dissolved it. Now, here's my vial with the cap on. That's a great cap, by the way. Now, did we see a color change? Did we see an energy change or feel an energy change? Did we see a precipitate form? Did we see bubbles given off? And the answer to the question is they're all no, so we didn't. All we did was dissolve. So you need to remember that liquids, the molecules are farther apart, but they're not really, really far apart like a gas. So what we did is we took the sugar molecules and we just fit them in between the water molecules. So now instead of having a new compound, we just have sugar water. All right? And this mass should have been close to zero because you didn't make a new compound, you didn't add anything to it, you didn't take anything away. At least you shouldn't have in your procedures. The last part is part 6. Part 6 is Alka-Seltzer and water. So you had, in this part, you had a half vial or a cup full of water, and in the cap, which you weighed separately to start with, you had a quarter of a tablet of Alka-Seltzer. And in that quarter tablet of Alka-Seltzer, you weighed them separately, and then you mixed them together and left the cap off loosely when you mixed them together, and you should have saw bubbles being given off, and you should have saw a little reaction going on. You may have even seen a little bit of heat, maybe even felt a little bit warmer, depends how sensitive you are. All right, so what we had here is we had in the cup, we had X's. And the X's from the previous one was water, so X is equal to H2O. And then in our little cap, we had, say, a tablet. Okay, and here's a solid. This is going to be our Alka-Seltzer. So the 0 is equal to the Alka-Seltzer. All right, we abbreviate that with AS. Then we mix them together. So we put the cap on. And you should have, there was water still in there. But now, because you put the solid in there, these molecules are running into the water molecules. Okay, so they're starting to move faster because they react with water really easily. Okay, they don't need a lot of energy to do that. So they start running into each other. And when they're running into each other, they start giving off some gas. You guys should have saw bubbles. All right, so this is my arrows for bubbles. You should have saw bubbles giving off. And the bubbles should have escaped because you put the cap on real loosely. So now when we're done, really what you see is a clear liquid, but that clear liquid is not just water anymore, because we saw bubbles given off, which is a sign of a chemical reaction, we probably do have some water left over, but not much. But now we have some salt, which will represent with this triangle, so a salt gets formed, which should be like with a magnesium, and the bubbles that were given off, these bubbles right here, the bubbles that were given off, so we'll represent those with squares. So these bubbles given off, these were carbon dioxide bubbles. All right, so we had some salt that got into the water because we made a new compound, and we had some CO2 given off. So this is the gas that's given off, that's CO2. Now, in this lab, there should have been some big ideas you should have realized. First of all, the whole time you measured mass. What is mass? Well, if you watch the mass video, mass is your number of particles, or the amount of matter in a substance. So we weigh that on our scales all the time. The law of conservation, in your own words, what's the law of conservation? Is basically that what you start with, you need to end with, unless something external happens, like, say, for example, in the Alka-Seltzer, we lost the gas. If we captured that, it would weigh the same. In the sugar lab, we should have weighed close to the same from start to finish, and so on and so forth. So law of conservation is basically saying what you start with, you need to end with, unless you lose something. What are the 4 signs of a chemical reaction? Well, energy change is one. Color change is another. A precipitate being formed is the third. And the fourth one is a gas or bubbles given off. The 4 parts of a graph, we'll talk about this in the next video, so don't worry about that one as of right now. But what does qualitative and quantitative mean? In this lab, you observed lots of things. Those are qualities. So qualitative has to do things with you observe, like color changes and bubbles and things like that. Quantitative has to do with numbers. Okay, so qualitative is going to be observe things, whereas quantitative is going to be numbers. So we mass things. When we mass things, we get numbers from that. And remember, numbers with or in addition to units, like grams or meters or liters or something along those lines. Okay, so that was the rundown of the Mass Lab. Hopefully you guys got that. Watch the video again if you need a repeat, and we will see you guys soon.